Okay, we're going to look at something called suitable domains. Now, already from functions, we've talked about numbers that go into the function and numbers that come out of the function. So the numbers that you sub into the function, they come from the domain set, and the answers that you get at the other end are the range. So if I had 3, 4 and 5, and let's say the function was to add 3, I would get 6 in the range, 7 and 8 in the range. So the numbers that you plug into the function, they're in the domain. Okay, so we're going to look at suitable domains, and that can also be termed as restrictions on the domain. Okay, so best explained by getting right into it. So, a couple of things to be thinking about that we can't have in maths. You can't have the square root of a negative number, and we cannot divide by 0. Both of those will give us undefined results. Okay, so let's say I had a function which was f of x equals 1 over x, and then I said, write the restriction on the domain. Well, that means what numbers can you not plug into the function for x? Okay, so what numbers for x would be unsuitable? Well, we know that we cannot divide by 0, so that denominator there cannot be 0. Okay, the denominator cannot be 0. The denominator, which is x, cannot be 0. So it cannot equal 0, that's the restriction on the domain. Because if x is equal to 0, we've got 1 over 0, and 1 over 0 is undefined. Okay, so let's call that example 1. Let's try a second one. We've got g of x equals 1 over x plus 2. Write a restriction on g. Okay, so this is pretty simple again. The denominator cannot be 0, so the thing down bottom there cannot be 0. Now what is down bottom there? It's x plus 2. So x plus 2 cannot be 0. Now that can be solved just like a normal equation. So if x plus 2 cannot be 0, take that to the other side, change the sign. That means x cannot be minus 2. Now let's just check if that's true. Well, if x is minus 2, we get minus 2 plus 2 on the denominator, which is 0, and that is an undefined result, which we can't have, so we need to restrict that from the domain. Okay, so the denominator cannot be 0. Okay, the denominator is x plus 2, it cannot be 0. Bring that across, that means x cannot be minus 2, example 3. Okay, h of x equals 1 over x minus 11. We're going to write a restriction on h. Well, again, the denominator, which is x minus 11, cannot be 0. Bring that across, change the sign, which means x cannot be 11. Okay, now there are these examples. Let's look at one a wee bit trickier. Okay, let's say we've got k of x equals 1 over x squared minus 4. Okay, so the denominator cannot be 0. X squared minus 4 cannot be 0. Now this is just a National 5 factorising skill. That is a difference of 2 squares. So that's going to be x plus 2 bracket x minus 2 cannot be 0. X plus 2 cannot be 0, or x minus 2 cannot be 0. This is just like solving simple quadratic equations. Bring them across, change the sign. X cannot be minus 2, or x cannot be 2. Final answer. Okay, example 5. T of x equals 3x plus 4 over x squared minus 3x minus 10. Okay, now it doesn't really matter what's on the numerator, it's about what's on the denominator, and the denominator cannot be 0. So the denominator, x squared minus 3x minus 10, cannot be 0. Now if it is 0, that means we've got something over 0, which is undefined, and we can't have that. Now this is just simple National 5 factorising. Two numbers that multiply give minus 10, add together give minus 3. Well, that's minus 5 and plus 2. minus 5 plus 2 is minus 3, and minus 5 times 2 is minus 10, cannot be 0. Now that means this can't be 0 and that can't be 0, so x minus 5 cannot be 0, x plus 2 cannot be 0, bring them over, change their sign, x cannot be 5, and x cannot be minus 2, final answer, example 6. Okay, example 6, we've got 9x minus 1 over x squared plus 8x plus 16. Okay, so exact same again. The denominator cannot be 0. So on the denominator, x squared plus 8x plus 16 cannot be 0. Two numbers that multiply give 8, multiply give 16, that together give 8, that's 4 and 4. 4 times 4 is 16, 4 plus 4 is 8, cannot be 0. Which means x plus 4 cannot be 0, and exact same, x plus 4 cannot be 0, which will give me the same result, which is x cannot be minus 4. Okay, example 7. Okay, example 7. G of x equals x over 3x squared minus 14x minus 5. Okay, so the denominator cannot be 0. 3x squared minus 14x minus 5 cannot be 0. Okay, so factorising again, 3 times minus 5 is minus 15, so this is back to National 5 knowledge. I'm looking for two numbers that multiply give minus 15, add together give minus 14. And those two numbers then are minus 15 and plus 1. Now the way you've been taught this, I believe, is to drop the 3x in there and the 3x in there. Okay, then you look to factorise further. The second bracket cannot be factorised further, so you just write it down again. However, I can take out a common factor 3 here. 3 into 3x goes x, and 3 into 15 goes 5, cannot be 0. Which means x minus 5 cannot be 0, or 3x plus 1 cannot be 0. Which means x cannot be 5, 3x cannot be minus 1, and bring the 3 down, divide, x cannot be minus 1 over 3. Final answer, example 8. Okay, so this time we've got t of x equals 2x minus 1 over 6x squared plus 19x plus 10, write restriction on t. The denominator, what's the denominator? That's the full thing on bottom. 6x squared plus 19x plus 10 cannot be 0. Okay, so let's think about this one. 6 times 10 is 60. Two numbers that multiply give 60, add together give 19. Take your time with that. Two numbers that multiply give 60, add together give 19 is definitely 15 and 4. 15 times 4 is 60. 15 plus 4 is 19, so plus 15 plus 4. Drop 6x in there and 6x in there. Okay, then look at both brackets. Can they be factorised? 6 and 15, I can take out a common factor of 3 there, and 6 and 4 I can take out a common factor of 2. So 3 into 6x goes 2x, 3 into 15 goes 5, 2 into 6x goes 3x, and 2 into 4 goes 2, cannot be 0. Okay, so 2x plus 5 cannot be 0, and 3x plus 2 cannot be 0. 2x cannot be minus 5, and x cannot be minus 5 over 2. 3x cannot be minus 2, and x cannot be minus 2 over 3. Final answer. Okay, so you're going to have a go at these ones. So in each case, the denominator can't be 0. So for the first two, that's it's up to ones that can be solved just like simple linear equations. And then you've got a difference of two squares, and then some trinomials. Take your time and have a go.